Up until now, all of our URLs followed a similar pattern, that pattern being defined in our routeconfig.cs file in a lone map route call named default. And you can see that it follows this pattern where we have the name of the controller that should be invoked, the name of the action method that should be invoked, and then optionally an ID for certain types of methods that need to work on a specific entity in our system. So whenever you combine that pattern with default values that are defined below it, as well as optional parameters, then you have a very clean, very expressive URL that connotes the structure and the purpose of our application. And that's one of the main differentiators between the default routing mechanism in ASP.NET MVC and the default routing mechanism in ASP.NET Web Forms. So, fundamentally a route is different than a path to a physical file. In ASP.NET Web Forms, the user makes a request using a URL, and that typically means that there is a .aspx file along with probably a code behind file that's there and that will handle that request from the user. In ASP.NET MVC, a URL along with an HTTP verb like get, post, put, or delete doesn't really serve up a file per se. It doesn't have a file that handles the given request per se. Conceptually, it takes an action inside of the system. And so, just a quick side note, you can also use routing like we see here in ASP.NET MVC, also in ASP.NET Web Forms now. It's kind of a new feature, but that's a topic for another time. The default is that incoming requests are handled by pages, ASPX pages, that are basically a handler for that particular request. But, okay. Side note over. You should think of a route as a layer of abstraction over the functionality of your application. In other words, URLs have meaning in the system. They're just not random file names. They're kind of another type of user interface, so to speak. And so how a URL is formatted is actually pretty important. You're describing the functionality of your application by the URL that you design. The route's definition is used by the MVC framework runtime to invoke the correct application logic. That application logic is divided into classes called controllers, and they're further divided into methods called action methods or action result methods. And so if a user wants to take an action in the system and invoke some action, then and if they're familiar with the URL structure of your application, then conceivably they could just type in their best guess for the interaction that they want to make with your application into the location bar of their web browser, and then ideally that particular action would happen on that particular entity. And so when you achieve this, it's called a hackable URL, and that's a good thing. It means that you have an application structure that's logical, it's well thought out, and it can be understood by an end user. And so we're going to actually pick up this topic and talk about a little bit more about designing URLs, designing them to be RESTful and what that really means. We'll talk about that in the next lesson. But in a nutshell, the benefit of a well-designed URL is that a user who needs to take action in our system could probably figure out how to achieve that once they understand, once they become familiar with how our URL structure works. So by default, we rely on this pattern that we've been looking here on the route config file. And this pattern-based approach that we take here in defining routes is known as convention routing. And so when we use the term convention, what does that mean? They're typically conventions that are employed in order to make the route work. So what are these conventions? Well, first of all, there's that URL pattern that we looked at. And you create it with a series of parameter placeholders, these little guys between the curly braces. That is a parameter placeholder, and then segment delimiters, which are simply just forward slashes. And then also you can add string constants to define URL patterns, and we'll look at that a little bit later. Now, optionally, there are a list of defaults, and you can see them defined below. That's another convention so that we can route the incoming request to the correct class and method by inputting it in two special parameter placeholders for the controller and the action. And if those aren't passed in, then we can default them to a specific class and a specific method to handle that incoming request. And then optionally, there's also a list of parameters that you can pass in as arguments to an action result method. And then optionally, and you don't see it here defined in this default route, there's also a series of route constraints that you can add, and that will limit the ways in which a route will match a particular URL segment or parameter. However, as we'll learn in another lesson, there's not just this convention-based approach, but there's also another way, a newer way to define routes through a scheme called attribute routing, and it allows us to define routes in close proximity to the actions. So what does that really mean? Well, in a nutshell, here we're defining routes in a file called routeconfig.cs that sits in the app start folder, right? But we have these actions that are these routes are being routed to, defined here in these controller classes. So what if we actually define the routes that a particular method, action result method, should handle next to or inside of the definition for this action result method? What if we use attributes instead to say, hey, I can handle these types of routes? Well, there you have the essence of attribute routing. And so you might find instances of attribute routing a little bit more flexible than convention-based routing, but again, we're going to come back to that idea a little bit later. Let's just hold on to that thought. In this lesson, we're primarily going to focus on the URL pattern and the defaults for the parameter placeholder in this lesson, but at the end of this, we'll chat briefly about route constraints. All right, let's start with what we already know about routes so far in this series of lessons. We've talked about routes, and we've talked about how important they are. Not only do they route incoming requests to the appropriate application logic, so they help the routing system figure out what controller and action result method should handle an incoming request, but they also are important in formulating the outgoing HTML that's emitted from our application for URLs that need to be created. So just hopefully you remember that from a previous lesson. Now, in many cases, this default URL that's defined here, or default route rather, is it works just fine for most applications. I mean, we've been able to use it up to this point so far and accomplish most of the things that we wanted to accomplish. Simple CRUD operations on a specific entity in our system, the product entity. But you can also change, first of all, change the shape of this default route, or you can add additional routes to this collection of routes called a route table that's being passed into this method. So each route that you map is added to the collection of routes called a route table, and then in that route table is used by the MVC framework whenever a new incoming request to the system is handled, and it will look at each of the map routes in the order in which they were added to the route table to determine which route will handle it, and furthermore, which controller and action and parameters need to be passed into the correct controller and action result method. Okay, and so in an incoming request, it goes through and it looks at all the routes that are defined in the route table, and it doesn't find a match, then we'll be passing back to the user a 404, an HTTP 404 response, which means can't find it, page not found. All right, so URLs, both incoming and outgoing, are matched against routes in the order of their definition in the routeconfig.cs, and the first match wins. So you would create your most specific routes at the very top and your most general route definitions at the very bottom of that list. And obviously testing a lot helps make sure that you've got all the bases covered and that there's not an overlap between the various routes that you've created. And you'll see that most of the time whenever there's confusion, and honestly, routes are one of the more confusing topics in ASP.NET MVC, and that's why I pushed it so far back into the series. A lot of the confusion comes in because you're anticipating one route that you've mapped to handle an incoming request when a different one, maybe one above it or below it, in the route table is actually handling it. So that can be a little bit tricky. But at any rate, back to the matter at hand, route mappings recognize URLs as a pattern of segments that are separated by this / character. And then inside of each segment, you can have parameter placeholders like we talked about before, or you can have literal strings or some combination of the two. Now, the controller, as I said, and the action parameter placeholders have a special meaning inside the MVC framework since they are needed in order to route the incoming request to the proper application logic. So when you think about adding additional routes or customizing this default route, you can do a couple of things. Again, you can introduce additional segments. You can introduce literal strings into segments. You can also combine parameter placeholders into the same segment using some sort of literal character or string to separate them. We'll look at examples of all of these. So we've been working with the notion of products with our Acme application at the very beginning of the series. And so I want to carry that thought through here in this project I've created called Custom Routes Example. If you take a look at the models folder where we have our product class defined, I also have this product manager and the product class. Now I've added a new property called category, and I've set the category equal to either widgets or gadgets, just as magic strings here, so we can find all products that are of type widget or all products that are of type gadget. Okay. Now I'm using that here to design some routes that will flex our routing customization muscles a little bit. And I want to admit up front that the examples that I'm going to show you here, I'm not all that happy with. They're kind of weak. Sometimes they're a little bit nonsensical. I was feeling particularly uncreative when I built these examples, but I really couldn't come up with anything better, so forgive me. I'm hoping that at the very least it illustrates what's possible and how to accomplish that using the routing system. So first, what if I wanted to allow a user to view all products by category? So we have a list of products, and we can get to that by just going to /controller/index. But what if I wanted to split that up into categories and only show the two categories first? You select a category, then you can find all of the products inside of a category. Well, then I would need to add another map route. And so let me paste one in here. I'm mapping a new route that I'm calling categories by ordinal, and it really will do a couple of things for us. If you were to type in just our domain name /categories, then you would go to the categories controller and the index action result method. Now, as you can see, since I'm not using a pattern placeholder here like I am below, the default action will always be index whenever this particular route is employed. So that really puts a lot of burden on the index action here to handle the various cases. And let me show you where I've defined that here. So you can see between lines number 13 and 33, I've defined this index action result method to handle 3 different cases. And this, again, I want to point out that this is a pretty weak example, but frankly, once you start wandering outside of the conventions that we learned at the very outset about routing, then things can start to get a little precarious, and this is a good example of how it could get precarious. So again, just want to emphasize here, if you just type in /categories, you're going to come to this particular action result method, and it's going to evaluate that category is null and ordinal position is null, and so it's going to execute this first this first chunk of code, block of code, and it will return a view called category list that will just list out the two categories. So here we're just grabbing all the products and saying, hey, give me just the category properties of each of these, and then give me a distinct list of those. So there should only be two, widgets and gadgets. All right. Now, if I were to type in /categories or click on a link that's /categories /gadgets, for example, then we're still going to come to this index action result method, but the category won't be null anymore. So we'll execute this second block of code, which will just return a list of products by category, and it will return this view called product list. And then finally, if you were to go to /categories /gadgets /1, you would be able to then view the ordinal position of the second item, zero base, second item in the collection of gadgets. So that situation is addressed here in this third block of code, where we're getting a list of products from the product manager by category, and then we're going to get the which item in the list it actually is. So the ordinal position. The first item would be 0, the second item would be 1, the third item would be 3. So we're not looking this up by the ID of the product, but merely its position in the list of products that match this where clause, looking for the specific category that was passed in. Okay, so hopefully that makes sense. And just to kind of refresh your memory here about this route, you can see that we've set both the category and the ordinal parameters as optional. The action will always be index, and the controller will always be categories when it comes in with a literal string called categories in the first segment of the URL. Okay, so let's run the application. All right, and here is our default route at work. All right, but what if we wanted to see, whoops, what if we wanted to see categories? All right, so now we can see a list of both of the categories, widgets and gadgets. What if I wanted to see all of the widgets? Well, then I could click on that, and I could see foo and baz are actually products. Now, if you hover your mouse cursor over, you can see the first item, foo, is position 1, so its ordinal position is 0, and you can see the URL that's being constructed, /category/widget/0. Baz is categories widgets 1, and so you can see if we click on that, we will get then the details about that particular widget. Okay. Now, why would you want to do that? Again, you probably would never want to do this. I'm just illustrating how you would go about customizing the route and passing parameters into an action result method to spit out the results that we're expecting. But I want to take this one step further. I'm going to add an additional route. It's going to look very similar, but there's going to be some subtle differences to it. Let's go back to the route config, and I'm going to paste in this second route. Okay, and let me actually move this over to the side a little bit. Okay, you can see that it too begins with the literal string categories, and it also will accept the name of the category as the second segment in the route. However, notice this third segment, it has a literal string detail dash, and then whatever comes after the dash will be used as the ID that's passed in as an optional parameter to our action. And here again, we're hard coding the action to an action result method called details. So you never really pass that in through the URL itself. You don't pass in the controller either. Those are hard coded whenever this particular route is engaged. You're merely passing in the name of the category and then the ID. And so, if nothing else, this particular route will allow you to do something special. It will allow you to have multiple products in your system with the same ID as long as they belong to a different category. So the category will be a differentiator here. And you'll see what happens whenever you provide an ID that's not available for a specific category. All right, so let's go ahead and run the application again. And I might also suggest that you might expect some behavior that won't happen here, and we'll talk about that soon. So category slash widgets, let's go there. Okay, now you might be wondering, how is it that this was produced? Or furthermore, if we were to go just to slash categories, how is this list of categories produced? If you take a look at the details action result method, it doesn't have all of this logic for those first two cases that we defined here. It merely deals with that last case where we're actually passing in both a category and an ID. Well, the reason why that particular URL or route rather is ignored and passed to this second route is because the incoming request doesn't match. So here again, I'm counting on the categories by ordinal routes to handle the category widgets case. So by adding this string literal here to our third segment, it changes the route in so much that it can't be a default route anymore. While the ID part of it can be optional, the fact that it requires a literal string in that third segment is a hard requirement, and so the URL doesn't match that hard requirement. It falls through to the very next route, and we'll see this happen again here in a moment. We'll show another example of it. All right, but at any rate, these two, and let me just go ahead and show you this, how this works, because I never really went all the way through this example, but we'll go widgets, gadgets, and then I'm going to go detail dash 123. All right, and so the foo product is in the widgets category. I could also do, and I happen to know the other item would be 345, and there's Baz. That's another product inside of the widgets category. But what if I were to do 123? I'm sorry, 234. All right, that product, that product ID is not in the widgets category. It's in the gadgets category. And the way that we've implemented our details method is that it's going to first of all look for, it's going to have two items in the where clause. First of all, make sure the categories match, and then make sure the product ID matches. And when we don't have both of those matching, then we're going to get an empty product that we pass into the view, and that's why we didn't see anything whenever those when we had a category that didn't have a matching product in it. Okay, so again, just wanted to emphasize some of the gyrations and the permutations of this idea. But these two examples in the route config that I just added here, they demonstrate adding segments that are filled with parameter placeholders as well as literal strings inside of our segments. But as I mentioned, you can also get creative and combine parameter placeholders into a single segment and separate them by a literal string. And the easiest way to illustrate this is just to go to that default route and just go ahead and add dashes in between each of the parameter placeholders. So now let's run the application. We're going to get an interesting 404 error, or 403 forbidden. You can't look at the directory. Well, how come, wait a second, how come we didn't get the defaults to kick in? I mean, after all, we still have the controller and the action are defaults and the ID is optional. So why did we get this crazy message? Let's see if the other version of this works, where we type in home-index-1. All right, that works. That gives us a list of all products, even though the 1 is an odd item. Let's see if we can just remove the -1 from this and see what we get from this. And we get a 404, it's not found. So what's going on here? Well, if we take a look at, again, at the pattern here, by introducing a dash in between each of these segments, it's kind of like what happened before with that details, where we make it a hard requirement to add these items. So even if ID was optional, or these are already added by default, the fact that we don't have a route that can accept anything without including the dashes in that route, then we're going to get a 403 in the case of the root, or a 404 in any other case. All right. So hopefully that makes sense. Now let's try one more thing here, just for fun. Let's see what, I'm not really sure what will happen here. Okay, what if we did home-index now? Okay, home-index works now because we removed the dash from this last segment and we made ID into its own segment, which is optional, and therefore we're able to just go home-index and it would work. Okay, so hopefully that all makes sense. Take a look at this slide. I want to show a more practical example. Here's a scenario where you have fundamentally different URL shapes for different types of data. So imagine that this is a storefront and you want to have a shape of the URL for a shoe versus the shape of a URL for pants. So you can see that in the first case I can say shoe / male / dress / black / 10 / triple E, and then / whatever the ID of the product is, 1, 2, 3. Okay. You could leave off any of those segments and you would see, like, for example, all men's shoes, all men's dress shoes, all men's dress shoes that are black, all men's dress shoes that are black in size 10.5, and so on. All right. Now, I want to call your attention to the second URL. It separates the waist measurement by the length in that last segment using an X, which usually means by. So you could say /pants / jeans / 32 by 36. All right, so a tall, thin dude. And that feels like a natural way to represent this type of information. But you also should be forewarned. Is this really a hackable URL? This might not be obvious to an end user who's attempting to hack the URL. If the user gets the waist and the length mixed up and puts the length first and the waist second, then the pair of pants that they order might have a 36-inch waist and a 32-inch inseam, which obviously wouldn't be what a tall, thin person would want. Okay. So finally, well, what I would say is that it's a better idea not to get too fancy with your route design or with your URLs, and that you should test to understand the limitation of the routes that you're designing. The more fancy you get with those URL designs, the more likely you're going to hit some sort of limitation, the more likely it'll be difficult for an end user to hack through your URL easily. It's just not going to make as much sense the more segments and the more complex it is. So as the old saying goes, just because you can doesn't mean you should. All right. So finally, for this lesson, you can add route constraints to a route definition that limit the ways in which the route will match a particular URL segment or parameter. So we could force, in this particular case here, we could force the ID parameter to be of type of a number. So you can see here I've added a comma on the end of this line, passing in an additional parameter as an overload to the map route method. And here this constraint is to set the ID equal to this pattern, and this pattern is going to be a regular expression. So in this particular case, you couldn't pass in the controller, home/index, home-index /Bob. It would have to be /123 or some numerical value. Okay. Here, let me paste in one more map route that illustrates the use of constraints, and we'll put that right above the default here. So this is a good example of only allowing the correctly formatted dates. So here you would have a map route called blog, and you would see all the blog posts for the year, month, and the date. And here's the controller, it would be blog, the action would be index. And then here you're limiting by constraining the types of values that can be added to year, month, and day. So for example, with month, you couldn't just put September 3rd. So 2014, September 3rd, right? You'd have to put the 09, and then 03 for the month and the day, respectively. All right, so that's constraints. And this is a pattern-based approach towards defining constraints. There's actually another way to do it by defining a class that implements the iRoute constraint interface. It's not hard to do once you see some examples online, but I'm not going to demonstrate it here. You can search online for some examples if you ever need this degree of control over your constraints. So the moral of the story is that you have a tremendous amount of flexibility and control over the routes that you create. However, I would encourage you to keep your routes, again, as simple as possible, because you could experience unintended consequences. You could create some long, confusing URL that would be difficult to hack through, to communicate to somebody else. They can miss a segment when they're typing it in. It generally would make it difficult for the end user to find what they're looking for. And not everybody is a fan of this implementation of routes. If you take a look at this URL, here's a quite opinionated view about how and why MVC routing is problematic. I recommend that you take a look at this article. If you know where the trouble spots are, I think you can avoid them, and also it's going to help you come to a deeper understanding of how routing actually is working under the hood, and again, where the rough spots are. So now that we've discussed how to map new routes, I'm going to spend a little more time talking about RESTful URI or URL design. What qualities make for a well-designed URL? We'll talk about that in the next lesson. See you there. Thanks.